In this video, I'm going to explain the V-Carve technique for creating wooden inlays. I will also demonstrate this method by making a coaster with a butterfly inlay. V-Carve inlays have two big advantages. The first is you can create complex inlays with sharp corners and multiple parts with a single piece of wood for easy assembly. Second, because of the wedge shape of the inlay, they can tolerate gluing alignment and machining errors quite well, even in thin pieces of wood. If you would like to skip the next section explaining the background on how V-Carve inlays work, jump to the 9 minutes 30 seconds mark in the video to get to the CAD CAM tutorial. If you want to skip all the way to the machining section, jump to the 22 minutes 40 seconds mark. First, I'm going to go through some theory of V-Carve inlays and the basics of how to machine them. So in this diagram, the blue arrow represents the V-bit and the brown rectangle represents the material we're going to cut in. And this is generally how a V-bit cuts. And it leaves a channel with angled edges. So we're going to look at one of those edges a little more closely. And if we split this horizontally down the middle, so we split the depth of the channel, so here's a line representing that, and then we take the material that's above the line, so we color that yellow, and we rotate that around. You notice that it's a perfect fit into that channel. So this observation is the key to designing V-carved inlays. Alright, so we're going to define a few terms to help us machine these. First is that line that we created is really called the artwork plane. And so this is the plane where you'd create your designs or any shapes that you want to have the inlays look like. So once that artwork plane is defined, we'll notice that the inlay, how it was machined, is really formed above the artwork. And note, since we had to flip it over to fit inside the channel, that we got to remember to mirror the artwork horizontally when we're working on the CAD and CAM. Also, that the base pocket is formed below the artwork plane. So now that we've looked at that, we can see that both parts can be machined separately. And so you just have to pay close attention to that artwork plane when you're setting up the machining process. Okay, so looking at the base, this can be machined with a usual standard V-Carve operation. And looking at the inlay itself, so this can be cut by first flipping it over. And so this is why we have to invert the artwork. And now we want to machine kind of the inverse parts of the wood. So we want to leave proud the parts that we're pocketing out of the base. So when we're doing this, we also don't want to cut all the way through the material. And so by leaving this kind of base at the bottom of the inlay, this allows us to have multiple parts to the inlay all attached together, and so we can glue them in all at one time. And another thing to note is that the inlay needs to match the shape of the artwork we have at the bottom of the V-Carve and not at the top. So this means when we're machining the V-Carve, we need to do a start at the depth equal to the inlay thickness. So there are also a couple of things we need to do to make this method more practical. Because we machined it as is, we've talked about, there could be errors in the depth or the widths of sizes, and then the inlay won't turn out as well. So a few things to add to make it more practical. The first one is usually called the glue gap, and this is at the bottom of the inlay. This also doubles as a gap to allow for depth of machining errors, as well as when you're inserting the inlay, sometimes you don't get it in there in a perfect angle, and so this channel allows you to have misalignments, slight misalignments, and the inlay still looks great at the end. And to accomplish that extra gap, all we do is add a little depth to the base pocket when we're cutting the inlay. And another important thing to add is a gap between the base and the inlay backing. And this is because after the glue is dried for the inlay, I usually take a bandsaw and insert it into this gap, and it allows me to cut off most of the inlay waste material. And this can be done by adding some what's called flat depth to the V-Carve operation, and essentially just a little extra depth beyond where the artwork plane is. And I'll go through that in a little bit more depth here in a bit. Okay, so let's go over some of the basics of how we're going to machine these. So first the base. So here's the base, and this is what the dialog looks like in either V-Carve or Aspire. The main components is essentially the cutting depths. There's a start depth and a flat depth option you get. And so for the base, the start depth is really the depth to which we want the artwork plane to be in the material. And so in the base, that's 0, because it's at the top of the surface. And the flat depth is the depth that we want the V-Carve to cut to. And so in this case, it's really the inlay depth plus the glue gap. And for the example I'll be using in this video, the inlay depth is going to be 1/10 of an inch, and the glue gap is going to be about 50 thousandths. So the total flat depth is 0.15 inches. Alright, so we'll look at now the inlay part. So we're going to machine this flipped over. And we'll bring up the dialogue. So this is the dialogue again from V-Carve or Aspire. Again, now we got to set the depth, start depth, and the flat depth. And this is really the key to doing VCarve inlays. And so the start depth is the depth at which we want the artwork plane to be located, and that is the inlay depth. So for this case, it's 0.1 inches. And then we want to add a little gap to be able to cut off the backing from the inlay, and so that is the flat depth, and in this case is another 0.1 inches. And note that I'm using the exact same tool between the base and the inlay, which is a 60-degree V-Carve bit. Alright, and one other thing to note, you should be careful is each V-bits, they can cut to different depths, and so you want to make sure that your inlay depths and your gaps are all within your bit's capability. For example, in the base, there are two components, the start depth and the flat depth, and that's equal to the inlay depth plus the glue gap. And so those two added together, in this case, are 0.15 inches, so we just have to make sure that the V-bit can cut at least 0.15 inches deep. And similarly for the inlay, so we have the inlay depth, which is the start depth, and then the flat depth is the gap for cutting off the waste material, so we have to add those two together, and we get a total depth of 0.2 inches. So in the case I'm using just a 1/4 inch V-bit, and it has a cut depth of a little over 0.2 inches, so it'll work well for this example. But for deeper inlays, you're going to need a larger V-bit. And this is what the base and inlay parts should look like after they are cut out. Next, I'm going to show you how to design and create the toolpaths for the coaster base, and this is done in either Vectrix Aspire or VCarve programs. So first up, set the width of the material to 5 inches and the height to 4 inches and a thickness of about 1/4 inch or whatever your material is. Then I usually put the 0 point in the lower left corner. And then hit OK. After that, we're going to create the outer profile for the coaster, which is centered in the material and the diameter of 3.7 inches. So create that. And then I'm going to create a little chamfer around this profile. So I'm going to create another 2 circles just slightly larger at 3.74 and then 3.66. So if I just do a V-carve between these 2 lines, it'll give a kind of a small chamfer around the outside of the coaster. So I'm going to close that, and I'm going to move these 2 circles to a new layer, and I called it the border chamfer. You can create a new one there. I've already created one there to quickly move it. And then next I'm going to create kind of a decorative groove around the outside. So we're going to do that by creating another circle at the same center. First at 3.5 inches, and then another at 3.4 inches. All right, I'm going to select those and then move those to a new layer. And then we'll just call that Deco for decoration. Maybe change the color so you can see it. All right, and then next I'm going to create a kind of a guide for where to place the artwork or the butterfly. So I'm going to create one more circle for that. And the diameter for this circle is going to be 3 inches. All right, so the next is going to import the artwork. So I'm going to import it as a vector. And there's the butterfly. So you notice this, while it is centered in the workpiece, it doesn't look quite centered because of the larger wings at the top. And so I'm just going to shift that down a little bit by selecting it all and using the arrow keys just to kind of visually center it a little bit more in the coaster. Looks about right. So it's touching the guide circle there. All right, so now this is the design of the coaster itself, and we're going to generate the tool paths for it. So we're going to make 2 different tool paths. We're going to do some V-carving for the chamfer, this groove, and the design itself, and then we're going to cut out the profile. So the first thing is the V-carve, so we're going to select the vectors for that. Select each one by holding down Shift. The important things here are to make sure the start depth is 0, and then your flat depth, set it to the thickness that you want the inlay to be, plus a little extra space for the glue. So in this case, the inlay thickness is going to be 0.1 and the glue space is going to be 0.05. So those add up to 0.15 inches. All right, then calculate that. And then we can preview that toolpath. All right, that looks pretty good. So we'll close that down. And next, we're going to look at the profile. So we're going to set up the profile. For this one, we're going to do a start depth of 0. A cut depth, we're going to go all the way through the material, plus about 25 thousandths, just to make sure we get all the way through. And then I have selected an 1/8 inch end mill here. And this is going to take 5 passes. I'm usually pretty conservative on how many passes I use. And then we'll also add some tabs. So first we got to select the profile. I'm going to edit the tabs. So I usually put in about 3 tabs on a coaster's. And I usually add a ramp of about a 1/2 inch. And hit calculate. And it just gives you a warning that it's going to cut all the way through, so we hit OK. Now we can preview that toolpath. And that looks pretty good. So the base of the coaster is ready to go. Okay, now we're going to make the inlay part that goes into the coaster. We're going to make this out of maple. And the width of the material is going to be 5 inches, height of 4, and a thickness of 1/4 inch. First thing is to bring in the artwork. Once the butterfly's in, because we're going to insert this, flip it over. When we insert it into the coaster, we have to mirror it horizontally. So this is almost already symmetrical, but I'm going to click the flip horizontal button. It does flip it. Alright, now I'm going to create the zone around the butterfly that I want to clear out. And I pick a fairly big one because I use a bandsaw to cut this inlay part out before I insert into the coaster. So the region is going to be about 3 3/4 inches in diameter. That's a bit big, so what I'm going to do is cut down the top and the bottom parts of the circle. Just a little bit. And I'm just going to quickly trim off those extra regions. Okay. Now, you can just V-Carve this if you would like, but I don't like to V-Carve it directly. I like to be able to control how deep each pass goes with the clearing tool, especially for if you want to do this with really hard woods. I find that if you go too deep on the clearing cuts, I can break bits or other things. So what I make my own kind of regions. So to do that, I just select the artwork and then I use this little offset tool. And the first offset is 0.08 inches. So this gets it outside of kind of where the V bit will cut. So I offset that. And I just have to delete some of these little extra parts that show up. I'm looking for the outside line. Then I select the outside line and I offset that again by about 1/10 inch. Okay, so what this line out here and this line out here represent is what I'm going to use to clear with the larger end mill. So I'm going to move these to a different layer. I just call these the clearing vectors. And then this right here is going to be the outside of where I'm going to V-Carve. So I just move that to the V-Carve boundary, just to make it a little easier to see. Alright, so that's all we need for the CAD, and now it is time to create the toolpaths. So the first thing we gotta do is do the clearing pass, and so we're gonna do that between these two blue lines. So we're gonna do that with a pocket. Pocket out between this blue line and that one. And we're going to go down to a depth of cut, which is 0.2 inches, and this is going to be the total that we also want to do the V-Carve. So this comes from the fact that we're doing a 0.1 inch inlay, and then we want 0.1 inch sticking out from the inlay to give us a gap to cut the bandsaw, go with the bandsaw. So this is cutting off the backing of the inlay parts. And I'm going to use a 1/4 inch end mill, so we'll take 2 passes. So if you're just doing this with a regular V cut and using a clearance, you wouldn't get these two passes because you're going to start depth is going to be 0.1, and so it only thinks it's cutting 0.1. So this is why I prefer this method. Alright, so calculate that. And we'll preview that cut. Okay, so now we're going to do the next cut, which is the V-Carve. So this would be a V-Carve. And what we're going to select here is this outer boundary as well as the original artwork, which you can do by just clicking on the layer that I just shift clicked the layer and then the outer boundary. And here, this is the important part of setting up the inlay, is the depth start is the thickness of the inlay. So that's 0.1, and the flat depth is how much it's going to stick out in the end. So that's 0.1. And I'm going to use a 60-degree V-bit, same as on the coaster. Calculate that. And then we can preview this V-Carve. And there we have it. You can look around the edges, and it should have cleared away all the extra material. That's why we moved that boundary out just a little bit. And it looks good. So now we can just select these toolpaths and save it out for machining. And that's it. And again, here's what the final base and inlay parts should look like. Next up, I'm going to show you how I make them with a CNC router. The process begins by selecting a piece of 1/4 inch walnut and maple. They are 5 inches tall and 4 inches wide. I'm going to cut the base first by clamping it on the bed of the machine, homing all the axes, and then setting up the Z and then X, Y 0 points. Here's the 1/4 inch 60-degree V-bit. I use a homemade laser guide to help quickly set the X and Y 0 points. And now we're ready to start the machining. Here I'm switching to a 1/8 inch end mill to route out the profile of the coaster, and then re-measuring the tool length. Next, I'll make the inlay. For the clear out pass, the first bit used is a 1/4 inch end mill. Since this is a new piece of wood, I re-zero all the axes. I switched back to the same 1/4 inch V-bit to finish all of the inlay edges. Next, I hand sand the parts to remove any excess chips. Using the bandsaw, I cut out around the inlay. The two parts should fit together snugly without any gaps. Then I use a paintbrush to spread the glue into the base. I use Titebond 2 wood glue. I don't like to use Titebond 3 because it dries to a much darker color. Back to the bandsaw to cut off the inlay backing. This step is much easier if you leave the coaster in the original workpiece and don't cut off the tabs first. Here I am sanding the edges and removing the remainder of the tabs. Next, I use a belt sander to remove the bulk of the remaining inlay backing and excess glue. I 3D printed a jig to help me hold the coasters, as I had sanded my finger a few too many times. I finish by hand sanding with 320 grit paper. And sand, date, and note the wood species on the back with a wood burner. The vacuum cleaner removes any remaining dust. Then I finish the coasters with polyurethane. I give the coasters 2 coats of clear gloss, followed by a coat of satin on each side. After the coaster is dry, I finish it by adding a 3-inch cork disc to the bottom side. Now I'm going to make a coaster holder. This coaster holder is meant to hold 4 coasters and is simply a rectangular block with a chamfered edge and slots to hold the coasters. And this is what it looks like roughly when it'll be finished. So these are the coasters sitting in the holder. Alright, I'll turn off the coasters now. Alright, here's what the coaster holder looks like with no coasters in it. and I'll show you the most important dimensions. Alright, it's about 3 3/4 inches long and about 3 1/8 inches tall. The slots are 2.719 inches by 0.355, and these dimensions I got by just trial and error by trying out different depths and widths. And the other dimension that's important is the depth of cut of these slots, and so that depth is 0.55 inches. So that is the design of the coaster holder. I use a jig or previously made coaster holder to help me quickly set up the saws to cut the 3/4 inch material to size. Then I use the same basic steps to route out the slots in the coaster holder. After rough sanding, I hand route a chamfer around the top edge. I finish up by hand sanding, sanding the back, and then applying the same coats of polyurethane.